Okay, in this video, we're going to talk about the exponential function for grade 10 mathematics. Let's start by defining our mother graphs as usual. So for our exponential, we're considering it as two graphs, but it's not that serious. It's a simple concept, and we're going to talk about it and why there's two for now. So as usual, you got your Cartesian plane, and the first graph we're looking at is y to the power x. Y is equal to 2 to the power x. Y equals to 2 to the power x. Now, the exponential graph works like this. Obviously, you put in your inputs and then you get a bunch of outputs, all right? Every function works like that. We're going to start by putting in, let's say, 0. 2 to the power 0 is equal to 1. So when x is equal to 0, y is equal to 1. Our first coordinate would be, therefore, 0 and 1. And as you plot points, for example, the next one is 2 squared, which will be 4, and then 2 cubed, which is 8. Your graph starts to rise at an exponential rate. If you use negative values, you get 2 to the negative 2, which is 1 over 4. So it decreases towards the left at an exponential rate. So the graph for an exponential graph, when the equation has a value over here greater than 1, is an increasing function and looks like this. Now, the x-axis in this graph is an asymptote. So basically, the graph gets infinitely close to the x-axis and closer and closer and closer, and that distance continues to decrease but never reaches 0. There's an infinitely small distance as you go further and further and further towards the left. Now, if you had something like 1 over 2 to the power x, which is a fraction, we're going to talk about this in a second, but if you got a fraction, then instead of being an increasing exponential, your exponential is decreasing. It's going from a bigger number to a smaller number. If you do realize it a little bit, it's a sort of reflection that way. So if you had to take this graph and reflect it across the y-axis, it looks a little like that. But the key thing here is there's an increasing form and a decreasing form, and that's the two mother graph ideas you have to remember. The standard form for an exponential graph is y is equal to a dot b to the power x plus q. Now, our three letters in this example, A, B, and Q, affect our graph. B is what you've been seeing, 2.5. So this affects the shape. So if our B value is greater than 1, it is an increasing function like we saw on the left. If our B value is bigger than 0 and less than 1, it's a decreasing function, and it's like the one you've seen on the right. So this is from B. B will always be a positive value. For example, if you had negative 2 to the power x, the 2 is our B value. That's going to be a positive 2 to the power x. That negative forms part of the A value. We're going to talk about what that does in a second. If you had negative half to the power x, again, the B value is just half. The negative is negative 1, which is our A value. So B is only the shape, as you've seen. Yeah. The Q value is the asymptote. All right. Now, it's the asymptote or the vertical here. So it moves your graph up or down by moving the asymptote. Now, remember we said the asymptote is x-axis. So in this case, the asymptote is y is equal to 0. If this changes, then this asymptote might go up, for example, and be y is equal to 1. Or y is equal to negative 1. But either way, it moves up or down. The A value affects the stretch, squash, or reflection. Now, as we said, Q, if it's positive, it'll move up, or if it's negative, it'll move down. Now, the A value, if the A value is greater than 0, if it's positive, your graph basically lies up above your x-axis or your asymptote. But if your value for A is negative, then your graph lies below your x-axis or your horizontal asymptote. Basically, when the a value, this value is negative, it flips the graph over the x-axis. So instead of being like this, it could have been like this or like that. Basically, it's a mirror image across the x-axis. All right, now with your exponential graph, the asymptote is given as y is equal to q. So in the standard one, y is equal to 0 because there is no q value here, so it's plus 0. But if there is a q value, then it's y is equal to whatever that q value is. The domain for an exponential graph is x is an element of real numbers. It continues infinitely in both directions on the x-axis. For the range, if our range, there's two possibilities. Remember, this a value flips our graph. Now if the a value is positive, so our graph is like this, range is y is greater than q. But if our a value on the other hand is less than 0, meaning now our graph has flipped, so now our graph is going downwards, okay, then the range is y is less than q, y is below the asymptote, the q value. Right, so these are the basic concepts for your exponential graph. Next, we're gonna learn how to sketch it and how to find the equation.